The piles are in 2 metre lengths. They're not too heavy to lift. Men can reach up to screw in bolts, and you will see that one connect. And you'll see how quickly that's going into the ground. The thickness of the walls of the pile, the tube thickness, is there mainly for the installation process where tremendous forces are exerted. The piles will take compression or tension. Different factors are applied to that. You will see the guys at the bottom making the final connection, and you will notice that the top piece is galvanised. This is additional protection in the aerobic zone where corrosion it takes place. In this instance, the piles come in 2 metre lengths because we have to, very often working with network rail in Britain, keep below the overhead wires. The overhead wires, the current switched off for safety purposes. On the side of the green torque motor, you'll see a dial. That dial is calibrated in kilonewton meters. The reading on that dial is vital as a check that the pile has been installed into competent soils to the required torque, which determines the pull-out, push-in ultimate force. This is the last pile of a group of 8. You will see the dial is increasing. The specified torque on this dial, on this installation, is 11 kilonewton meters. It's approaching that now, and it's important that it's averaged over the last metre. I believe the other piles have gone in and averaged 12 to 16 kilonewton meters, which is good news. You will see the guy now taking the final level reading using a laser level. This is often the way we check them. The installation torque rate, the motor rate, has been slowed down to give the correct reading on the dial. If you were to try and rush the pile in at high speed, you would get a false reading. So it's very important that the machine is slowed down during this final installation push. It's taken 3 hours to put in 8 piles, and shortly we'll be hoisting into place the superstructure, and you'll see from the size of that superstructure just what sort of forces